Uh, Good evening, everybody. Good evening, everybody. I hope we can hear me. Yeah. Good evening. Good evening, Adibowale. I hope you all can hear me. Hope you all can hear me. Um, Please, can I see a response? Can I get a response? Interesting. So I'm trying to check responses on YouTube. Trying to check responses on YouTube. Hopefully, network has to be good on my side. Okay, I'm audible. All right. Yeah. Good evening. Good evening, everybody. Trust we're good. Trust we had fantastic day, right? Trust the learnings have been going all great. Um. Oh, yeah. Thank you very much. Trust the learnings have been going all great. Um. How has RAG been? How has learning RAG been? Can I get a response? How has it been learning RAG? Anybody? I'm waiting for a response, so I really want to hear about what we've been learning on RAG. Like, what are the things we've learned, so I can see if we so far so good. Oh, okay. So any other like maybe I'm new to it. Okay. Well, I understand. Clement says RAG has been interesting so far. Well, really interesting. Nice, nice, nice. That's good to know. And I'm sure we appreciate why we do RAG, right? It has to do with has to do with trying to prevent hallucination as much as possible, because I mean, for a fact, when you're dealing with very like sensitive documents and you do not want, or you want your large language model to be precise, and you know for a fact that even with fine tuning, right, even with fine tuning, it's still not going to give you precise answers. So RAG comes into play, right? That's one of those things. That's one of those things RAG does, right? So yeah, so it's like one of those foundational stuff to learn. And most organizations now, especially the ones that use AI for their infrastructure, they leverage on RAG so that RAG can understand their old data, their old documents, and all that, and help give precise answers low hallucination. Embeddings and racks to convert raw text into vector, which computer understand. Excellent. That is very good. That is very good. So I'm just, would you want me to do a bit of refresher? I know Jumobe has done a very good job because I mean I'm seeing positive reviews. Martin trying my best. Well done. Well done on that. Um so would you want me to do like a review of RAG so that we can just catch up, right? Because we still have, yeah, okay, I can refresh. Okay, yes. If I get like 2 more years, I think I'll do a refresher. Okay. I think I need 1 more years, then I'll just do like a refresh. Okay, recap. Oh, okay, no problem then. So I'll use the presentation Jumobi must have used, right? Because that would be nice. To be nice to catch up with this. But I would just not dwell so much on it. I would just, I would kind of be fast at it. I'll be kind of fast at it because I know she has already introduced this. So if you're still lost, please go back to the video. Right. See, please, can you see my screen? 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 Can't see my screen yet. Oh, okay. Please. No. Interesting. Please. How about now? Oh, you can see me, not my screen. Please. How about now? How about now? Okay. Let me stop. I'll stop sharing now. Now share again. Share. Please. How about now? Can you see my screen? Interesting. Interesting. What's going on? Present. Not yet. What's going on? I'm sure my network is not bad. Okay, let me stop sharing again. I'll try again. I mean everybody can hear me, so that's a win. Oh, what's going on? Share slide. Oh, my computer. No. Share screen. Okay, I'm trying out share. Share. No, share. I wonder what was really going on. Apologies, let me just try and fix that. Hey, what's going on? Guess it's a technical glitch, but I'll try and refresh. Maybe it's a technical glitch from my end. Apologies. Chrome. Share. Yeah, okay. I think I'll do that, please. Let me leave the call and join. I'll leave the call and join. Sure, and restart. please. I hope you can hear me. Right. Hi. Sorry, I had to actually restart my system. So let me try and share my screen again. Check YouTube comments. Okay. Please, I hope you guys can hear me. Please, I hope you guys can hear me. Please. Okay. Thank you. Apologies. Right. Screen. I don't know. Maybe I was having laptop issues, but and that was one disadvantage of not always shutting down your laptop. And it usually gets to me. Well, because maybe sometimes I'm very busy with my system and I have a lot of things running. And when I open it, I just want to like kickstart. And of course, sometimes it costs my laptop to hang. Crazy. All right, so let's just do a refresher. Sure, Jumobi has done a great job on this. Right. So, all right. So just brief introduction. Oh, can I zoom? I should zoom in. Please, I hope you can see because this is like the best I can do. Can see me? Okay. Thank you. So, brief introduction to RAG and its application. So, no agenda, really. We don't need it. But LLMs, we already know what LLMs are, right? Type of artificial intelligence program that recognize and generate text, among other tasks, right? Then, of course, we now have the multimodals. Multimodals are it's not just text now, your voice, your image, and all that. Oh, interestingly, we'll be going into text. Sorry, we'll be going into voice and image, generation. So I hope we're excited about that. So LLMs, of course, they have their limitation, not updated to the latest information, right? Hallucinations, domain specific, not accurate information. Sorry, domain specific, most accurate information. So of course, because it's trained on a large chunk of data. That's why if you're trying to even fine tune most of these LLMs, I'm sure you must have heard of FinBet or FinGPT. That's like financial GPT, financial pre-trained model, right? So all those things is through fine tuning. So to make the LLM like sort of understand, have like nuanced knowledge to a specific domain knowledge. So the LLM, as large as it is, of course, you still need to fine tune so that it can understand a particular domain. So yeah, source citations, because it's trained on a lot of things. So to even start citing those sources, it's a bit crazy. And of course, update to latest information. So if you will notice, this, which is a concept of RAG, I don't know if Jumobi must have explained. One beautiful concept of RAG um, is how most of these large language models now can easily do like a search on the internet, right? When you ask ChatGPT, or especially Gemini, ChatGPT, Claude, when you ask them something and they know that they don't have it in their memory, they quickly do like a search, right? Through the concept of AI agents, they quickly do like a web search. So that's one of those things. So updating like long training time, of course, because it takes time. Even all these updates we see, like Gemini 3.0 came out yesterday, right? Gemini 3.0 came out yesterday. So it takes time, right, for all this. And also I think 5.1 came out last week. That's 5. So that's chat GPT 5.1. So all these things, they take training, they take a lot of time to train and all that. So it's can be, it can be very, very taxing, especially because we need to always improve, the parameters of this model so that at least they can perform better. So RAG, retrieval augmented generation. So it combines the technique of retrieving information and generating process. So most times, right, even when you connect your RAG, you do your vector database, your embeddings, you still need to connect it to an LLM to actually make sense out of it. You, there are different use cases. I think after now, I'll give us a paper to read, right? I'll give us a paper on I think it's just my only two assignments for you guys. Oh, Grok 4.1. Yeah. Grok actually 4.12 just came out too. So I think I'll give us that RAG paper to actually understand the whole concept of RAG. So it's it's a concept of using RAG for drug information. I'll give us that to read. So yeah, so in RAG, the model retrieve relevant information from a knowledge base. Of course, um, one keyword you'll be learning when you're working with RAG is something they call knowledge base. So I'm going to rush through this because we need to be done with the notebook that you must be started with. So I'm just doing this run through so that everybody can catch up. In case you still need to catch up on some things, I'm very sure Jumo B has done a very total explanation to this. So you can go back to the previous video, watch it, right? Because I still have like other new things that we need to learn. So, oh, sorry. Okay, why rag is important? I mean, of course, I talked about preventing hallucination, right? That even fine tuning, because even when you fine tune some of these models, they can hallucinate. So I like to put it in this kind of concept that I have this very big, like this is the concept of fine tuning, very simple concept. I have this very big well, right? And or let me just say I have this very big data. Then I now use, especially when you're fine tuning, most of the times fine tuning as good as fine tuning can be, depends on how large your data set is. And now now one of the disadvantage of fine tuning is when you're fine tuning with a very small data set and you now dump it in a very large data. You're trying to fine tune a small data on a very large model. Trust me, information from that large model can start leaking through, and that your fine-tuned model will start to hallucinate. So you get the reason why what's the name now? RAG comes in to help solve such problems, right? So RAG architecture, basically this is a basic custom RAG architecture. Can be more complex than this, right? But this is any RAG model you see or any RAG system you see, trust me, this is what they follow. Very simple. This is what it follows. There's your embedding model. There is your vector database. Your vector database is basically just helping you store those, your unstructured data, especially when it comes to text, right? This is looking at RAG in concept of text. So, and there is a retrieval and there is a ranker, and there is also like a re-ranker. So re-ranker helps like does this kind of similarity search. It helps to search words that are quite tailored to your search query. Think about your search query being like your prompt, your query or your prompt, right? Um, it helps to rank it to the it helps to rank it to what is to your search to what is much similar to that query, right? Um it helps to bring data that you're trying to that data you're trying to search for. So when it passes through a ranker, it makes sure that that data tallies with that search, that query itself. So when you talk about ranker, there are a lot of ranker systems. Right? One that is coming to my head, which is because I use it almost every time, it's called Jira. Jira ranker. It's coming to my head because that's what I use almost every time. But there are a lot, really. There are a lot. And you also now pass it through an LLM to make sense out of it, right? Because LLM will now help you put that ranker that query in like a much sensible text or more sensible answer. Then you get the response. How does RAG work? So there is a retrieval component and there is a generator component. So the generator component basically is like what plugs into the LLM, and the retrieval, that's where you get the vector database, the ranker, that's the similarity that does the similarity search, that ranks the similarity search, that makes sure that whatever you're searching for is accurately tailored to that query or prompt you've given it. Right. So okay, this is like a summary of component retriever, ranker, there's re-ranker, right? There's re-ranker actually, and generator and external data. Basically, these are basically the things you'll be dealing with when you're talking about RAG. So external data, new data outside LLM. Oh, so yeah, basically then vector embeddings. I'm sure you will be more stuff stressed on because most of the time when you're dealing with when you're dealing with RAG, you definitely talk more on vector embeddings. Sure, you must have explained vector embedding. So I really would not have to start wasting my time on vector embeddings, but it's a very, very interesting concept. Just helps to encode those numeric those texts, right? Because we already understand for a fact that computers only understand zeros and one. Can I get the RAG notes? I don't know if this presentation has done. Okay, I think after today to be shared with us. So I mean, we know for a fact that computer only understands zeros and one, and because of that, right, there is a need to convert this our text to at least numbers, to numerics that computer will understand, quote and unquote. Oh, interesting, just me chipping this. This is out of the scope, but there is a concept of using quantum computing. So quantum computing is to like allow computers, do more than just zeros and ones, like understanding in complex numbers. That's the whole concept of quantum computing, simply put. It would be nice if someone can talk about more. If you're very familiar with quantum computing, please, you can just talk about it on the chat. It's a very beautiful concept. So okay, back to RAG. So yeah, so basically we have to convert those texts to what? Right. So the concept of vector DB, vector DB database that stores these embeddings of words and phrase and documents. So vector DB, think of vector database as your think of it as your how SQL works, how Postgres works, right? Think of it like that, basically. Simple. Just think of it like that. So it allows you to easily, when you query this your RAG, it allows you to quickly get them, right? Quickly search through the data and get these vectors, right? Remember, embeddings help us to will I say tokenize? I don't know if tokenize is the right word right now, right? But it helps us to just break this text into numericals, right? So there are various vector database. There's Chroma. Chroma is kind of popular because it is free, right? Chroma is very free. Python is, I think there's a free tier, and there is the one you have to pay for. You can check that out. Let me, if I'm permitted to, let me see if I can open Pinecone here so we can see how Pinecone is. Pinecone systems. Sorry, I'll share my screen now. I just want us to see how Pinecone is. Let me stop sharing this one. So I'll switch. Stop sharing. I just want us to see how Pinecone is. While I'm showing you Pinecone, like there are a lot, but of course there's always going to be that bias, right? Because of what I'm very much used to. Or what I use on the norms. I use um I use ChromaDB because I mean it's free. Even the paper I'll be sharing with us, it was done with ChromaDB, but um I don't know why this is taking so much time to load. But please, maybe we would have to. I wanted to. Okay. I think it's my internet really, but this is like how ChromaDB looks like. Oh, oh, my screen has gone. Oh my goodness, what was wrong? Sorry. Um, what's wrong? Interesting. Please, can you hear me? Blank screen. Oh, my bad. Can you hear me? But can you hear me, please? Yeah, blank screen, I know, but please, can you hear me? If you can hear me, please, that would be nice. Okay, okay. I think I was trying to share the Pinecone screen again. Please, crossing my fingers. How about now? Please, can you, if you cannot see my screen, can you see my screen now? Can you see my screen now? Just tell me you can see my screen. Okay. Yes. Oh yeah. Okay. Yes. I'll assume you can see my screen now. So basically, this is how Pinecone works, and you can even see that even OpenAI use them, Querel use them, Asana, Gong, like basically like if you're trying to do like a vector database. So if you want to scale vector database for production, interestingly, why I like them is that they host most of their vector database on AWS, and the AWS is faster. But because of AWS is fast, right? It's expensive. So yeah, it's one of those things. Rag, I mean, Chroma is good, right? If you're just doing like small projects. The thing is that when you're dealing with, and you can see like basic use cases that they have here that you can go through. I do not have to start doing. Let me even see if I can log in here. I don't know if this is the account I have for Pinecone. I'm not sure. I'm not sure. I'm not sure if this is the account I have for Pinecone. Please let me know waste our time, please. But you can check it out. You can check it out. Please, you can check it out. I'll just switch back to the slide. But you can check it out. I just wanted to show us how Pinecone is. Right. So but you can check it out. I'm switching back to the slide now. I'm switching back to the slide now so that we can continue. Just to confirm. I think it's going to take another time again for the screen to start loading. Please, can we see my screen? I hope it has not gone blank again. I hope it has not gone blank again. What's the Pinecone used for? So I was explaining that you use Pinecone for um use Pinecone for vector database. It's a database, a type of vector database. That's what I was saying that we use Pinecone for. Right. Then there is the Elasticsearch. I don't think I've used Elasticsearch or these with it. I don't think I've used any of them. No. There's Children's. I don't Children's. Yeah, if I'm pronouncing it well. I think I've used that once, but I can't. I mean, so there are a lot. It just depends. It depends on what you're doing. So there's okay. The concept of the retrieving all these vectors from the database. That's when you query it so that it does the relevant searching. So it ranks the search based off what you're querying. It does like a similarity search, right? To be able to retrieve those numericals from the vector database. So again, please, I'll be skipping a lot of these things because I'm sure Jumobi must have done a very total explanation on all this. So the RAG ranker, right, um, ref- kind of ranks the search based off their relevance and similarity. There's also still the ranker. There's also still the ranker. Maybe after, if someone can remind me, I can show you how Jira is too. Right. So once it does all the search, then you now plug it to an LLM. Sorry, you plug it to an LLM, then the LLM will make sense of what the query is. That's the RAG, basically the generator. Right. So this is how it works. This is like a basic base chat application. We will be building something similar to this. We're building something similar to this, but we'll just do it based off a like a small PDF now. Try to query our PDF, ask it questions on PDF on our PDF and all that. So that should work. That should work. So Steps of how basically a RAG system work. Step one, user sends query. Step two, the chatter will forward the query to the vector database. Then RAG will retrieve from the vector database. Then the LLM will generate the response to the LLM. The LLM will give you a response and all that. So yeah, this is just very very simple. So here is a very lovely part that explains the difference between RAG and fine tuning. Even if I've kind of explained why we even use RAG, especially when we're trying to be specific about certain things, than fine tuning a model. So, objective fine tuning aims to adapt a pre trained LLM to a specific task or domain by adjusting parameters based on task specific data. The RAG focuses on improving the quality and relevance of generated text by incorporating retrieved information from external sources during generation. That's the objective. Training data, fine tuning requires task specific label data. So fine tuning can be supervised learning, all right, because these data are labeled. And examples to update the model parameters and optimize, leading to more time cost and time and cost. Because fine tuning is more of like, I don't say you're training a model, but yeah, you're kind of, I think I can put it in a layman term, or you're trying to train the model again, because now you now want it to you want the model to be nuanced to a specific task, right? So that's what it helps to do. Then adaptability. Fine tuning makes LLM more specific. Sorry, I didn't even talk about, okay. RAG relies on combination of pre-trained model and external knowledge base. Right. So we really don't take too much time modifying or retraining. Sorry, Miguel. Can you come again? What do you mean by that? Sorry, this particular slide has not been sent on LMS. If it has not been, I think after today's section it will be sent. Yes, you get the slide on LMS. You get the slide on LMS, sure. You get the slide on LMS. Right, you get the slide. Sorry, Miguel, can you come again, please? Modifying or retraining. Just tell me what you mean. I must have said something and I can't even recall. Oh, nice. So I have it on good note that it has been uploaded. Interesting. So for adaptability, fine tuning makes the LLM more specialized and tailored to a specific task or domain. RAG maintains the generability of the pre-trained model by leveraging external knowledge, allowing it to adapt to a wide range of tasks. Yeah, you just change the knowledge base. Um, Model architecture. Fine-tuning typically involves modifying the parameters of pre-trained LLMs. Another word for fine-tuning, modifying, retraining. Yeah, basically. Thank you very much, Miguel. Yeah. So RAG combines retrieval and generation components with the standard LLM architecture to incorporate retrieval mechanism. So say RAG is just I don't want to say a lazy man way, but trust me, it's a very beneficial way, especially when you're trying to curb hallucination that fine tuning comes with. So benefit, enhance relevance, improve quality, versatility, efficient retrieval, dynamics, update, trust and transparency, customization, cost effective, conversational AI in terms of application of RAG, advanced question and answering. Yes, when I have like a PDF or I have like a PPT, a PowerPoint presentation, yeah, I can ask question. Content generation. So if I have a lot of documents and I want to summarize them, I want to do article writing, I want to do content recommendation, all those kind of things, right? RAG is good for. Then healthcare assists professionals in assessing relevance and latest medical literature and guidelines. So far, those medical literature are updated in the knowledge base, right? You get up to date information. So yeah, thank you. I think um I've summarized the slide. So I would go back to what we literally have for today, right? I'll go back to what we have for today. So now I'll just share my notebook. I think I would not be doing any live section, any coding live section. So apologies, right? Apologies for anybody that would have expected me to code along. But first off, can we see my screen? And let me confirm if we can see my screen. Please, can we see my screen? Okay, we can. Okay, thank you very much. So, for the people that said I should do a refresher, for the people that said I should do a refresher, okay, I should zoom in. Okay, no wahala. I would zoom in. So for people that said I should do a refresher, okay, but it's blurry. Okay. For the people that said I should do a refresher, I hope we already understand, rack basically, because now we're that kind of doing hands-on. I hope we understand. Please, okay, zoom. I've zoomed as much as I can. Oh my god, I would have to generate another token. Right. I'm sure I deleted the last one I used. I'm sure I deleted the last one I used. Okay, so let me go and generate another token. I'm not going to share my screen on how I'm generating token. We already know it. I've done it I always do it every time so that we can understand. I'm sure by now we are all gurus on how to use Hugging Face. I've been now. We're all gurus on how to use Hugging Face. Can I get someone to acknowledge on that? Ah, yes. Okay. Um, is the yes coming from being gurus on using Hugging Face, Mary? Oh, like we're all gurus. Nice one, nice one, nice one, nice one. Share us, please. I will share. I will share again because I would assume that we all should know how to generate tokens from Hugging Face. If you don't know, you will have to go back to previous videos. I mean, to be nice, to go back to watch the videos again, so that will give you better understanding. Please, are we going to continue with yesterday's notebook? No, it's the same notebook, right? It's the same notebook. It's the same notebook. Henry said small guru. Interesting. The black background. D-Max, please, what do you mean by the black background? Apologies. White backgrounds, I don't do well with white backgrounds because of my eyes. So please bear with me. I'm not wearing any anti-glare glass. So I have to dim my background. Apologies. I apologize. But the notebooks are being shared. So you can of course be able to follow. So yeah, I just generated my white background used yesterday. And yes, that's Jumobi. I'm sorry. Me, I can only use what's way up with my eyes. I apologize again. Miguel, we are not gurus yet. Though. In fact, I could learn some topics on. Okay. Yeah, thank you, Miguel, for this. Nice. So, okay, I think I must have mentioned it. Okay, Face has has a training. It has a training like academy, right? Where you can where you can actually follow up on how to how to do all these things on LLMs like NLP. There's a training on NLP. There's a training on AI agents. A whole lot of stuff. How to use these models. So yeah, Hugging Face is a very good learning platform to learn all that. Hugging Face is a very good platform to learn all that, right? So it will help. Trying to go through the chat so I can say how like if I'm not answering any questions. Okay, going on. Okay. So please, apologies for the black background, but please help me. Help me help my eyes. Thank you very much. And of course, the notebooks are being shared, so please. Interesting. Let me even check if there's a contrast. I mean, we can all see now, right? Okay, so I've connected my RAM. I've connected my notebook. Let me see if I need to plug in secret. Oh, interesting. I already have a secret here. I think must deleted it. Let me just delete it and start again. So of course we already know how we log in our secret. So yep. Interestingly, before Collab did not used to have this, secret key. You have to like manually do it on the cell. All right, Dmax, thank you very much. Thank you for saying you can manage. Please explain embeddings. I would assume you're just coming because I even tried to like explain it again. Omotosho, are you just coming? And if you're just coming, please just you can go back a bit and watch the embeddings video. I'm using my phone. I don't know anything yet, but I'm coping small. Precious. Have you been catching up? Have you actually been watching the videos religiously and taking notes and actually practicing? Omotosho, you just joined us. Is that what you're trying to say? Still at the beginning stage, I mean, I'm sure you must have. Just keep on watching the videos, to be honest. It will help. And Precious, thank you. We all started from somewhere. All right. Yeah, irregular, sir. Okay. I hope you are, but I'll explain. When we talk about vectors embeddings, it's basically trying to. I gave an explanation, simple explanation. I explained that computers really just understand numerics, right? Simple numerics, zeros and ones. They don't understand natural language. They don't understand our English. They don't understand our English. Now, embeddings help us to convert this, natural language, this text, to literal numbers, right? That computers would understand. Hmm? Do you understand the motor show? So now we make use of embeddings and vector embeddings. They've been trained. They've actually you can still classify them as a model because they've been trained on a lot of data. They help to now convert all these text to embed to numbers, to like numericals that can be stored in vector database. So they convert this text to vectors in quotes, right? They kind of attach like it kind of helps in tokenizing them, to breaking it down, after breaking it down, to now convert them to numericals that can easily be stored to the vector database. So with that literary illustration, it's a very loose illustration, right? But I hope you understand it like that. Omotosho. Please, I'm sorry about the white background, but sorry about the black background, but please cope with me. The white background really literally affects my eyes. I even have to cope with this slide. No time yet, but I'll learn at my pace. All right, precious. Thank you. So, Omotosho, I hope you understand. I'm taking my time. Please. Jude, the fact is that I've not really been following up. I hope you know that we'll be doing like an assessment, more like an hackathon, and that would qualify you for the bootcamp that will be happening ahead. So, if you have not been following, please will be watching the videos. Omotosha, I hope you understand what vector embeddings are. Okay, you're not saying anything. I'm curious, what are we indexing in the cell, in that cell under embeddings in our notes? So when I follow through. Okay, thank you very much. All right, so I'll just start by installing run anyway. I'll just start by installing what will be the necessary packages, right? That we'll be using. Okay, done. Then I will import the OS. Again, I'm apologizing about my black background, and also no, maybe oh, I'm apologizing about my black background, please. Alpha admin shared. I'm following you through. Okay, thank you. Those of us in the US won't take part of the hackathon. Miguel, you're in the US. No problem. Maybe there will be virtual. They will provide virtual for you. Active, passive. Okay, please, again, I'm begging you, just follow through with the black background. I'm really apologizing. Thank you. So, I'm sorry again, there will be no code along section because I want us to wrap things up. So we would import our libraries if we've already installed packages. So we import the OS, that's the operating system, the text wrap, the maths, TQDM, auto, NumPy. Of course, NumPy. If you notice, especially when we're dealing with vectors or numbers, all right, when we're dealing with vectors and numbers and like arrays, we'd always talk about NumPy. NumPy, basically, NumPy is not even my favorite. Um, Not my favorite. So I remember when I was learning NumPy, I really struggled with it. So it took me time. Then token, then tick token for tokenization. Then of course our organ face up. So I'll run this. Then also run our organ face token. So tokenization. I want to assume everybody understands tokenization. I want to understand. I want because I mean it's something that we've been talking about, right? And tokenization is a process of converting raw text into smaller units called tokens, which is a fundamental input element that models can process because of course we cannot just pass large chunk. We have to break it bit by bit. So in Hugging Face ecosystem, you use tokenizer via the tokenizer library or the transformer library to split text into subwords. Um, um, a token might represent a full word or subword. For example, learn. Then when you want to break learning, you break it as learn and in. That's like for any of it. That's not stem. Is this steminize? I can't remember if it's stemminization or something related to that. But yeah, it's something along that line. Like when you are breaking the stem of words. Okay, Motosho. Seems on Motosho, you've been very active on today's class. Okay, no problem. So and yeah, so spacing, punctuation, emoji, special tokens like beginning and end of sentence are all handled by tokenizer vocabulary and processing rules. And in your code, you already have something called tokenizer encode. I think I explained when we're talking about transformer model. We talked about the encode, the encoder and the decoder. Sure, we must have talked. Stemmatization. Thank you very much, Olajumoke. Thank you. We have NLP gurus here. Thank you. I really appreciate it. I mean, I feel very much encouraged. Like, yes, I mean, people are really following. So, token counts are important. Miguel says, Omotosho should explain tokenization in Yoruba to prove you know it. Okay. Now it will be a nice one. I wish, I wish if you could say it, or let's see if you can type it. TikTok is it? No, please. So TikTok is not the same as TikTok. It's just a very fancy. So you can create your own libraries, right? And you can create it with different names and all that, right? Python, as you all know, it is an open source language. Anybody can innovate around it, build their own package, build their own libraries. So maybe the person that builds it just named it TikToking because I mean it's it's fun, right? But it is not the same thing as TikTok. So counting token helps you manage document chunks such that you don't exceed limits and you keep your memory and compute usage, in check. So there are different kind of tokenizers. Please, there are different kind of tokenizers. There are a lot of tokenizers. There are a lot of tokenizers, and they would help. And I mean, I think this one we are using is CL 1000. So I think maybe it's string or maybe 1K text and all that. That's why it is called. But there are different tokenizers. So just to show us, I'm sure Jumobi must have because I'm still running a notebook, but I've added some things here. So I would have to be fast with this. I'll have to be fast with this. TikTok cut. Okay. TikTok in me. You impute your tokenizer. This is just to show you like um how um how tokenizers work, right? There you to show the original text. This is the original text from the sample. Numbers of token in this text. You will really, literally see how these texts are broken down. Then token IDs. Those are like the numerics that are assigned to these tokens, and how these tokens are decoded back. So please, again, I always talk about attention is all you need because that helps you understand your whole encoder decoder stuff. So I'll run this notebook. Oh, okay. So why tokenization? Okay, I'll run this notebook, then I'll explain. So why tokenization matters? Models have limits. Yes, we know that. Helps us to split documents into manageable chunks. Yes. Each token 4 characters in words. So this generative AI class we are currently learning in the 4th week, right? So numbers of tokens that are being generated from just this sentence alone is 15, right? Then the token IDs that are being assigned to it, the numericals. So basically, this is how vector embeddings work. Vector embeddings will now start assigning all these numbers. Don't worry, you will see how it works. Then when you now decode this because this we can call it as the encoding part, right? The encoding parts now because encode them with tokens encode. So when you now decode them, it still decodes it to this generative AI class. We are currently in 4th week. So I hope you understand the concept. What's going on? Please, right? I mean, thank you for making the class fun, but let's focus. Thank you. So I'll run this to print out the token IDs that are being mapped. So look at it. This you can see how the tokens are assigned. This has this token. Is has this token. Gener has this token. Retrieve has this token. AI has this token. Class has this token. Even the comma itself has this token. We are currently in the 4th week. Even they have their own token, right? So that's how we now tokenize these words. So it's simple. And please, this again, we have different tokenizers. So it's not just this one. There are a lot. Trust me. Go to Hugging Face, you will see a lot, right? So embedding is a numerical representation of text that captures its semantic meaning. I'm not sure. I hope we're still talking about embeddings here. Not just the word. It contains not just the word it contains, but what it's actually saying. Sentence or chunks that mean similar things land in nearby places in the vector space. Unrelated texts are further apart. In code, you loop over each chunks in your document, applying embedding models, then stack the resulting vectors into numpy arrays or similar. So it helps to helps to um helps to put this our text into like numerical representation. Like I have said, right? Computers don't understand natural language, don't understand text. It's the numbers they understand. So we can see from this notebook now, when you import the from sentence transformers, import sentence transformer. So we're going to be using the sentence transformer. Remember, I talked about this transformer model, the encoding, decoding part. Please, these are things I really like to talk about. Rita, please, you have not answered my question. Okay, Rita, please, what is the question? Rita, please, what is the question? So I don't move too fast again. Please, what is the question? Oh, okay. I would like to ask her, based on the notes you are creating for us, is it possible we create notes in coding by ourselves? Yes. Oh, yes. You do that with markdowns, right? You do that with markdowns or with this text. With this text, Olamide, I hope you understand. So with text, you can create your own notes. As simple as it is. So we have code, we have text, but when you create text, with markdowns, you can create your own notes in in the notebook. Sorry, Rita, please, what question? Okay, sorry. Okay, I think I've seen your question. Please, sir, can we also input numbers on embeddings to just the system? So when you say input numbers on embeddings, like, are you trying to say, okay, when you're like, can you embed numbers? Is that what you're trying to say? Is that what you're trying to say, Rita? But if that's what you're trying to say, well, you are not trying to embed numbers, because I mean numbers are like their literal words. I'm sorry, I'm not supposed to say literal words, but they are literally numbers itself that the models would understand them. Okay, yes. So the models will understand these numbers, right? So there's really no need for us to now start going through all those things, right? No need for us to start going through all those things. Um, so just so for numbers, okay, well understood. Okay, thank you very much, Olamide. So for numbers, you don't have to. So this is how embedders work. So yeah, we're using the Quen model. I think Quen is by Alibaba, and yeah, you see list of sentences. You see list of sentences like the cat sits on the mat, the feline rests on the rock, the dog plays in the yard, Java is my second best programming language. I don't agree. For me, Sha. SQL is my third best. Nah, no me. This is generative class. So embedding. So you now see how all these sentences are like encoded into vectors. So I'll run this, right? So it's might take a bit of time. I'm running this. So let's see how that would go. Remember, we want to see how the sentences are being captured in the embeddings. Okay. Okay, it is loading our embedding model for us. I think this is even quite large. We still have a lot to do. We're still even covering what was covered yesterday because I'm just doing it for us to be able to follow. I'm not sure. Okay, when sentence are in can we when sentence are in box brackets, why can't we use triple quote? To be very honest, you can actually use triple quotes, right? These are more of these variables now, they are in list. You can use, I don't no, I don't think right now we can use triple quote because remember that I was even trying to pass this variable. Yeah, because we're assigning this variable, we're assigning this list to a variable that is sentence, and we're going to pass it here as our I'm going to pass it here so that our embeddings would understand that it's coming from where is this list we're referring to. So no, triple quotes would not work. Yeah, would not work here literally. But I think it can, right? Because I mean, I think it would. I think it would work, but I think it will work. But basically here, it's better because this list of sentence are just passed as a variable sentence, and it's easy to just plug it in here. So um oh, Omotosh, you tried it. Did it work? Omotosh, did it work? You said you tried it. Did it work when you use triple quotes? Oh, it worked. Okay, that's nice. Nice, 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 nice. Okay, so the sellers ran, and you can see the original sentence, and you can see how it embeds all this text. See the shapes now. This is the embedding shape. The shape is just more of like how it is. Like say X and Y in quotes. X and Y in quote, yeah. Henry, are tokenizers standardized, i.e., irrespective of the tokenized word used for each? So are they standardized? No, I won't say they are standardized because the tokenizers themselves have a way of calculating, of doing like this very large calculation on assigning tokens to to um to text, so, or how they even break down this text. Sorry, how they even break down this text. So it depends on the token, right? Like that one that, let's say, sorry, generative. Some tokenizers might not, that one was broken down as gener, then ative. Some might even just break down gen. They can break it down into like three syllables. So it all depends on the tokenizer, to be honest, and how it was trained. So it's not standardized, so to say. It all depends on how it was trained. So you can even train your own. Please, I'm not getting the long response. Please, I'm not getting these long responses. What did you change from the cell to get the results, sir? Please, which of the cells are you talking about? Which of these cells are you talking about? Please, if you can answer, Lufunke. So yeah, I mean, from here we can see how the sentences are being tokenized, right? Sorry, are being embedded, like how the vectors are how it will break them down, right? Like it's not even showing you how it tokenize them, but trust me, embeddings they first tokenize before they now start assigning vectors, but you won't see it here. So all these things, trust me, they've been broken down. Please, what shape are we talking about? Cause I can't see any. So this shape is just like it's just talking about this, the list of tokens, and just talking about this. I've highlighted what the shapes I'm talking about. Miguel, can you see the? Oh my god. All right, so I'll move to efficient retrieval with FAIS. That's FIAS. So FIAS is like, I think, I let me check for the full meaning. Can't really remember. Oh, okay. It's Facebook AI similarity search. So this is like our own similarity search tool. It's open source, right? So once you've turned your text to chunks into embeddings, the vectors. So one way to actually now start searching, right, is through like doing for easy retrieval, right, using a search index. So like I'd explain, when I input a query or a prompt, like, so to get answers that are very similar to my answers, this would work. This would help, right? This would help. So we use Fias to build search index from all our embedding vectors. Remember that these vectors are stored in a database. Um, this index means that when users ask a question, Fias can quickly find the most similar chunk instead of us manually comparing the questions to every single chunks one by one. So basically, this is just computer helping you to search. So Fias can be used in different ways in measuring how close two vectors are. So basically, it just does like a yeah, yeah, yeah. Thank you, Omotayo. Thank you, Omotayo, for that. Thank you, Omotayo, for that. Let me go through the. Yes, Olamide, thank you very much. Facebook AI similarity search. Okay, thank you. So okay, let me just continue. I like the energy in today's class. It seems everybody's a guru. I mean, it's nice to see the growth. Nice. Um. So fears like can be used in different ways in measuring how close two vectors are. So this kind of reminds me of the old concept, because I think I must have talked about the old concept of attention is all you need, and how it came to where they're trying to do sequence to sequence, trying to see how to match in terms of predicting the next text, to know the next text that comes in, right? That was basically what gave birth to, when predicting words, that was basically what gave birth to attention is all you need paper. So yeah, so this helps with that. Yes, it is, Miguel. Yes, it is. So for example, for um um sorry, okay. So what's going on? Sorry. Okay, yeah. So for eluding distance now, this L2 distance, think of it as straight line distance. So Similar distance, more similar. So when the vectors are actually kind of pretty close to each other, you can get a search. Mr. Bash, why are we okay? Why are the numbers not chronological? How do we know the vectors that are close in semantics, or do we just leave it to the embedding? Yeah, so it literally does that for us. We don't have to start budging about the math. But trust me, if you are really if you Olajumoke, if you are really concerned about it, there's a mass, there is like a mass, there is a mass attached to this. I can't really remember, but there is this mass formula that helps to, if you want to like, if you want to typically, I think with linear algebra you can even calculate it yourself. If you want to mathematically predict the next number to a vector, that can be done with math, but you don't have to bother yourself about this. The embeddings will, will do that. The similarity search will do that, right? It will do that. So you don't have to bother. But I mean, if you want to, there are actually ways of calculating it, but that's not like our focus right now. So how do I keep opening this? Close it. Inner product or dot product, we use this in code, index flat IPs. So it gives each word a score. The higher score, more similar. So it helps. Also, it ranks, like, let's say, for example, now let's say we've embedded this is a boy. Or let's say this is a or sorry, let me use a simple term, is a, and I have boy, girl. I have boy or girl. So based on how, like, if I've embedded them, we can be able to tell that, oh, since there is e there, that means it means that it's the next one to come in place is boy. I'm just trying to explain it in very simple terms. So that's how this similarity stuff works. Cosine similarity, interesting. So when it comes to a recommendation system, cosine similarity actually comes to play. It's nice to see that we're even seeing cosine similarities in NLP. So cosine similarity, another common way to compare embed is, cosine similarity too is like, it's a math. Like I said, there are ways to calculate all these things, but we don't have to calculate them. There are even formulas for that. There's a formula for cosine similarity. If you're very familiar with math, explain FAIRS again, boss. Okay, in simple terms, FAIRS is Facebook AI similarity search. So if you're trying to search how, you're trying to search embeddings that are kind of similar to themselves, when you query them, it helps to make sure that when you query the embeddings that are similar to that query, right, are what you would get. Kristen, I hope you get that in simple terms. So, why does this matter? Tokenization, embeddings, indexing, and retrieval is a pipeline that turns raw text into searchable vectors. Take note of this, please. I kind of like sad. So take note of this, please. With FAIRS, we store embeddings once, then we do fast lookup so questions can be answered. Remember, we have we we store, when we will store all these things into our vector database, and that will help. And that will help. So using a higher score means is more similar, yes. Then smaller distance means, or smaller distance more similar means erase rule. Makes it easy to explain what FAIRS is. So please take note of this. Higher score, maybe when he's assigning a score, that means it's more similar. Smaller distance, that means it's how smaller the embedded, the numbers when they are calculated is, means okay, they are going to be more similar. So it simply returns the chunk that is closest in meaning to the question. So if I run this now, this will come to play. So let me explain this. So you import FAIRS library, you import the numpy, then we're trying to create like a search index, right? Then the dimension, the embeddings dot, you want to see the shape of the embeddings. Then the first index flat IP dimension that was explained here, as we have here inner dot, inner product and dot product. Higher score, more similar. Then normalizing using L2 of the embeddings makes it much more better when we normalize it. Now, then the index 2, sorry, then the index 2 is for the embeddings that we are trying to get. So here is our query now. Like I said, like I explained, this just helps us to see like the vector that is similar to our query. So a cat on a carpet. Query embeddings encode, then normalize, and the query embeddings putting this to normalize it, so it makes it easier to search. So you get the score of the search, using K2. So K2 just rank it, like just gives you like two of the scores. Yeah, so two of the scores, yes. So it's basically just trying to rank. It's just basically going back to this, trying to rank the embeddings that are closer to this. Remember, this is what is all these sentences that we've embedded. Oh, sorry, it's all these sentences that we've embedded that we're now trying to like tokenize, right? Sorry, let's say tokenize. Sorry, that we're not trying to retrieve. I had to call myself back. So, a cat on a carpet is now showing us two of the sentences that are similar to that cat. If a feline rests on the rock. A feline is a cat. Rock too can be also associated with carpet. So you see how embeddings work. This is how Quen embeddings has already embedded or assigned embeddings to this queries. Oh, sorry, to this text, to these sentences. So to show that yes, it is similar. A feline is a female cat. Then cat fit on the mat. You can see that these two, they are very similar, but based on the search and based on the similarity search that Fias is helping us, it has ranked them as these are the two that are actually similar to this query from our sentences that are here. So let me even try to change the prompt. Let's say let me look at let me change this to something that has to do with coding. Let's say coding is a lifestyle. Let's see what the similarity search will be. Let's see what the similarity search will be. So it will pick, of course, it will rank it. It's even ranking it low, but it is ranking it to what I've said about programming languages. Java is my second best programming languages. SQL is my second best programming language. So now, like, we understand how this work, right? So we understand how this works, and we see how the similarity search works. So in terms of like complex, this is just as simple as it is. In terms of complex, in terms of complex document, that very ranker will come in. But we're not going to focus on the ranker right now, like I said. So this would just help. So we will now want to put all this together, like to create like a simple chart. To create a simple chart document, like with PDF. So I think this was already built with Graduate. This is Graduate, so we'll just see how simple gradual works. So um so putting this all together, putting the similarity search and the embeddings and the similarity search together. This was done gradually. So I'll have to install, I'll have to pip install this. That's the PDF, because the pipe PDF, because I'll be uploading a PDF. So you see from here, we import sentence transformer, import our organ face, import our PDF reader, import our files and gradule. We already know what gradule is. Please, on the query part, what is the score represented there? Like the score represented there is the similarity rank of what is there. Is the similarity ranking of what is there. I hope that is clear. Apologies, please. Can we have like, can we take like a bit of break, like 10 minutes break? Can we take 10 minutes break? So we'll be back by exactly 8:30, please. 10 minutes break. We'll be back by 8:30. So please, we'll be going on 10 minutes break, please. Let's go on 10 minutes break, please. Thank you. So let me see how far. Okay, I think we'll be done. Yeah, we'll finish. So go on 10 minutes break and we'll come back and we'll just finish. It's just to like put this all together so that we would understand. We're almost done, right? We're almost done. So 10 minutes break. Thank you. Right. Hello, everybody. Hope we are here already. We're back from our break. Let me catch up on what has been happening in chat. Um, okay, be you here 10 minutes back. We're on break. Class is currently on break. Okay. Now the numbers convert. Okay. Okay. All right. Nice. I like the fact that I mean we are even exchanging knowledge here. So that's very nice. I think I like today's class, to be honest. Everybody, it has been very interactive. I like what has been going on. You guys are giving me motivation. Thank you. Please let's continue like this. Right. Let's continue like this. It makes the class much more interesting. I mean when I see the interaction. Thank you. So yeah, we're back. Do we have to give people a bit of time? There's no time so that we can finish once and for all. Whoever does not catch up would go back and watch the recording. Okay, right done. Thank you, D-Max. Uh, all right. All right. So now we're putting all this together. We're putting in what we've learned from the tokenization to the embeddings, to the indexing, to the similarity search. But basically, what we're just going to be dealing with right now is more of the embeddings and similarity search. So we're going to be building a simple web base for this. We're making use of Gradio. We're using this we're not using the Quen, right? We're using this vector embedder for what we're going to build in all mini LM. I think it's very small, not what I would use on the norms, but this is small. This is small model for us to use. Even the LLM that we'll be using for inference, this is it. They are all got it from Hugging Face. They are not very strange, right? They're not very strange. So right, so okay, this print ready is basically just like a debugging message to show that yes, everything has been loaded. So once it loads everything, it should just print ready. Then the chunks, then the index none. We're not using any index. Then read the PDF or the text files that we'll be using. Malanka, I hope I make friends that will help me get better. I mean, amen. But I'm sure you're on the group, so you guys would definitely be communicating. That would make so much sense. That would make so much sense because I mean, when you learn these things, like I mean, guys like Omotosho and I think Miguel, few names I can remember, right? I mean, they've been vibing along. So, and allow me to how do we get embedded models on Hugging Face? Very simple, just search. Just search. You see embedding models on Hugging Face when you search. Okay, you see. But remember, you have to put some things into consideration. Some very heavy embedding models are, they are GPU intensive. They are, let's say, they are computing. Yeah, yeah. I mentioned Miguel now. They are compute intensive, right? They are compute intensive. So you see those are the things you want to like consider. You want to start small, but if you're dealing with like very large projects that you have to scale, trust me, you will need very large embedding models. So basically this here is just going to read the PDF or the text we upload. So that's basically what this function here is doing. i don't think i I don't think I need to explain too much, right? But just passing the PDF, chunking them, passing them into chunks and all, then reading them, right? Then of course I think I've even explained this before. We've written this code for one of the things that we built. Yeah, yeah, we have. Then split the text into chunks. Then this function here is splitting the text into chunks. Then the chunk size will be, let's say, depending on the PDF you upload, the chunk size will be 500, right? This is the first day I enjoyed Mr. Bash class. Interesting. So, Lamide, what are you saying? You don't used to enjoy my class? Wow, I take that as a shade. So you don't used to enjoy my class? I think she showed us sentence transformers. Okay. So Olayinka, what do you mean by she? Are you talking about are you talking about Jumovi? Are you talking about Jumovi? Are you talking about Jumobi? Well, so just going on again. So this function here is basically to like process the documents, right? Once you've chunked them down, as simple as it is. Then this document just takes this read text that we must have defined over here, takes this function here exactly, takes this function here, then as read file. So this is just a debugger, like a debugger, just in case you cannot find any document to return error could not read file or file is empty, right? Back like castle strike. So part one of now that we've okay, so after we've done all the whole reading of our PDF and all that, so we'll now pass this chunk. Now we help to split the document and create embeddings, right, for our text, then normalize them first, normalize our embeddings with FAIRs, then build FAIRs index to rank them, then return document has been processed, creating this length of chunks is just like the amount of chunks that it chunks them down to be able to answer questions. Okay, you know what? If okay, since it feels like my excitement is really showing. The interesting thing is, yes, you might say I'm excited tonight, right? Because I mean, someone I've not seen in a while is around. Like I was supposed to pick this person, which is my sister, right? I was supposed to pick her from the from the airport. I was supposed to pick my stuff from the airport, but I could not because I had to facilitate this section. But I mean, she's back in Nigeria after like 3 years. So yeah, I'm excited. I'll get to see her after this class. So yeah, maybe you're right. Maybe that's why I'm happy. And maybe the happiness is reflecting. No, we're not extending this class to 10. Thank you very much. So, yeah, building the fears index that's for to rank them. Then also return like this debugger once it is ranked. Then document process created this amount of chunks. Then they're ready for no problem. I will. They're ready to for answering of questions. Then this is just the function to answer questions. All right. So this is function to answer questions. Then a debugger for it that okay, in case the document is not there, raise another debugger. So you notice that most of the time I always like putting in debugger is to show that sometimes when we write code and we really want to be sure that the code is working. I really want to be sure that the code is working. We would have to add debuggers to it, right? We'd have to add debuggers to it. So yeah, that would help. And please let's focus. Thank you very much. I mean, I've told you, I've shared the good news for you guys. So please let's focus. Thank you. Then find relevant chunks using FAIRs. That's basically what this is doing. Then this is going to give us like rank three ranking. I think I like to use 5 as my default. So I'll change this to 5. I'll change it to 5. Then the relevant chunks that are actually like almost similar to that once I query and it retrieve the relevant chunks that are based off what I'm retrieving. So like rank them, give me like 5 relevant ones. Then set my because it's obviously a chat, so I have to like set my system prompt Yeah, useful assistant answer question based solely on the provided context. That's provide the provided context that the embeddings will provide, right? And bring. Please, I need to finish this. And yeah, then context questions. Yeah, that's rule of the user, rule of the system. That's the model has been defined, providing the system prompt. Then the prompt that you'll be giving it provided here. Then of course we are very used to this response LLMs or chats underscore completion, then messages, and of course this have been passed to. Then temperature, we already talked about how temperature affects the, let's say, the creativity of the model in quotes. And higher temperature, you are giving the model liberty to, give you to be creative. But here is a like say a disclaimer. Honestly, if I'm dealing with retrieval, if I'm dealing with retrieval rack systems, I want to put this very low. I won't put it at 7 because I want to eliminate hallucinations as much as possible. So I'll put it as 2. Then answer, response, response choices, then return answer basically. So I'll run this now, as I've explained. I don't know if I have a PDF I want to put in. Let me see if I have. I like to use the attention paper. Let me see if I have that. I talk about attention is all you need paper in this generative class. Okay, this has already run. Okay, yes. Oh, so yeah, okay, I'm not even done. Oh. Okay, pip install graduate. Do I have to pip install graduate again? Why was this added? I don't think this was necessary because I think graduate has been installed. But okay, so now this is me. It's going to involve me like designing the whole graduate interface. Upload your document. I don't need to explain this, right? This is self-explanatory, to be honest. This is just you trying to. I think I talked about how can I learn how to code like this. Well, this I'll say experience, right? And the more you do projects, the more you get used to, the more you get used to coding. To be honest, when you do a lot of projects, you get used to coding. That's just the honest truth. Then the markdown. Basically, this is just you trying to customize how graduate interface should be. So I know I talked about the documentation, right? How the graduate interface should be and all that. So yeah, the text box. You can also customize your own the way you like. Helps. So I'll run this. So I have my guide running live here now. So I think it's loading. I'm coming. I'm trying to see if I have the attention paper that I can upload. Okay, I have attention. Yes, I have the paper, so I know what I'll be uploading. Okay, so I'll want to open this. I want to open this in a new tab. This link in a new tab. So let me share. Let me shift to sharing this tab. I hope you can. Please, can you see my new screen? The screen I'm sharing now. Can we see? Dmax, what is what? Please, what's the difference between ChatGPT and chatbot? I honestly do not understand. Well, if you mean what you mean, what's the difference between ChatGPT and chatbot? They are the same thing. ChatGPT is a conversational chatbot, as simple as it is. Okay, you can see my screen. Okay, now, nice, nice, nice. So let me upload my attention. Is all you need paper. Yeah, this one. So I've uploaded my paper now. Now click on process my document for me. Error. How? What's going on? Cannot show me error. You should not even bring out error. Okay. Document process created 66 chunks ready for question. All right. What question do you think? What questions do you think I should ask? I tried it on one of my PDF and I asked a question about Cloudflare incident yesterday. The model has that's why I said, please decrease your temperature. Don't do 0.7. Decrease it to 2 or even 1 or even remove the temperature. That's why it would hallucinate. Hmm? And Francis, is this Francis? Okay, Francis, sorry. So that's why to hallucinate Francis. Right. So please, what question should I ask? Okay. Let's say explain sequence to sequence, the sequence to sequence in the paper. So let me see if it will generate what I need as an answer. Ask about no Abba. Nigerian economy in attention is all you need paper. Abba, please now. That's not possible. This will take time because I mean it's going to take time to retrieve answers and all that. So yeah, one of those things. Ask about summarize the paper, um, ambition of the paper, summarize the paper. How can we cover or put an end into terrorism in Nigeria? Please, no sensitive topic in this class. Thank you very much. Honestly, this class would have been better if it was live coding. Ah, interesting. Teams uh, 8-3. I typically live code in my class, right? But because we have a lot to catch up on, right? That is why I cannot follow through. Like I can't like continue to live code because it's going to take a lot of time. Because once I code, I have to explain. I code, I have to explain. I code, I have to explain. Right. So apologies for that. Interestingly, there are people who will tell me, "Oh, just explain the code. You don't need to live code. No module named PyPDF because you did not pip install it. Go and pip install it, Clement. Pip install it. Run the cell above it that has the pip install PyPDF. Clement, do that. This your screen. I can't see the words. Okay, let me. Yeah, it's very tiny to be honest. Please, can you see now? So this is going to take a lot of time, right? Because it's going through a lot of chunks. That's just the honest truth. It's going to take a lot of time. So I think I might have to skip and come back. Or how long? Okay, let me just use this to answer questions in case you have any other questions. Let me see. Okay, yeah. I think it has answered. Oh, thank God. So this is too long. Context. The input system was passed through a stack of n encoders, each of the self-attention followed by a position-wise feed forward network hidden states. Basically, this is just trying to explain how encoding and decoding works, how the transformer model works. That is it. But I don't know why it is generating a lot of this text. Okay. But yeah, basically this is how it is. This is how it works. Sorry, I won't be able to ask too much questions so that we go ahead. Please, what can we ask the bot, please? Oh, nice. Why is attention introduced in model? Okay, I feel why do we need let's say why do we need attention in modern? Let me just phrase it as, why do we need attention in modern AI? I'm taking time to answer. Ask about me. Ask, ask about me. Ask about... Please, someone to show. Okay. So this is this is it. Attention mechanism in modern AI, such as self-attention and transformer, serve as three important purposes: learning, language of dependencies, align, parallelization of computation, blah 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 blah. Basically, this is just it. Yeah. Actually, it is still sort of hallucinating. No, I don't like how, because it's bringing some very irrelevant things. Well, basically, I think I will still have to decrease the temperature to. I will remove the temperature, put it to even zero, because it's going to be hallucinating like this. That's why when it comes to RAG, you really do not need to put temperature. Don't put zero, because you want like specific answers. You don't need the models to be creative. You don't need any creative responses, right? So let me just move share this tab instead. Let me move to our normal tab back. So I want to talk about a brief. Oh, we have like 6 minutes more. Let me talk about LangChain. I'll kind of give a brief about it. So LangChain document loader quick guide. So what is LangChain literally? LangChain is a framework for building AI application. If you're an AI engineer, you definitely must have heard of LangChain. LangChain is one of those frameworks we actually use in building AI applications. AI applications including AI agents, retrieval systems, and all that, right? So it's a framework for building AI application. It has many components, including document loader, vector store, chain, agents, memory system. It's really encompasses a whole lot of stuff. Why are we only using one small part? We're just using to like load documents. This is basically still the same thing, but just kind of giving a brief overview to what LangChain does. So LangChain is a framework. You can read about LangChain. You can check LangChain online. You can check the you can check the documentation online, LangChain documentation. So yeah, so what are we doing? LangChain document loader handles messy work of opening different file types, dealing with encoding issues, extracting text cleanly, returning a consistent format. So after loading, we use our own fairs and embedding approach that we've already learned. So if you want to learn about LangChain RAG approach, please check the official tutorial. So if you open the file, if you open the notebook, click on the link, you'll be able to see it. Please, can we I would appreciate if we can, my answers are short or like yours, Mr. Bash. Interesting. What kind of question? It depends on the PDF that you are checking out, and what kind of PDF and what kind of questions are you asking? And what kind of questions are you asking? Sorry, Gabriel, what can you not see? Questions can be asked anyhow on attention. No, no. Remember, we want to ask questions that are pertaining to the PDF, right? Not something out of the blues, or else it will start to hallucinate, to start looking for answer to give you. So one of even the graduates we do most times is just to make sure that once it doesn't find a document to retrieve, it just tells you, oh, this is not in your knowledge base. That would help to prevent hallucination. Okay, so LangChain community document uploader import. Okay, this is basically how you import documents. How you import documents using LangChain. straight to the point, no bluffs. So all those ones that we're using Pi PDF to load PDF. It helps to limit it. So there are different ways of loading, PDF, text, CSV, Excel, Word, JSON, HTML, URL from websites, multiple. I mean, loading multiple URLs and all that. So basically, it just helps to take care of that. So let's install the LangChain. So this is me just installing LangChain. Same question you asked, uploaded same PDF. Interesting, and it gave you short answers. Oh, that is quite interesting. Mary Bayo, today's teaching section was awesome. Let's do more. So interesting, Mary. You don't want live coding. You want me to just be explaining the notebook and be talking to it. Is that what you want? Oh wow, sorry to Tiolu Alashe. Oh, it's not on the notebook. Interesting. Don't worry, we'll share the updated one. We'll share the updated one. Thank you. So this is just a simple rack. So basically, please, you have to read the documentation. I might not be able to take you through LangChain documentations and all that, but please, you have to read through. Yeah, I will not. I would not advise anyone coding with their phone. But I mean, if you don't have the resources, you can still use your phone. But you need to get the laptop. I know it's not easy, but you actually need to get the laptop. So this is using LangChain. Still going to be using Gradio. Um, simple rag LangChain document loader with Gradio. So yeah, just for me to have all these have just been explained. Yeah, all these have been explained too. So it's basically what we've done before, but now using LangChain, right? But I think one assignment I'll give us against next class is please read up on LangChain. Read up on LangChain and just ask me questions that you want to ask about LangChain. Right. Ask me questions that you want to ask about LangChain. So that will work. So basically, it's what we've done already, but it's just that we just replaced it with LangChain. It's simple. We just replace it with LangChain. It's what we've done already. So I don't even need to start explaining all that. I don't have to start explaining all that. Right. Oh, okay. Oh, thank you. So it's loading the models ready. All right. So I'll just open this. Please, I'm very serious. We need to read about LangChain against next class, please. Yeah, LangChain framework. Go and read on the documentation. And I'll also be sharing. Okay, so now this is share to this share to start instead. So now this is the RAG channel system with running on LangChain. So I would upload my attention is all you need paper again. All right, so process the document. So 66 chunks, yeah. So let's just see what question can I let's just say summarize might not be let's explain encode explain encoder in the transformer model. So let's get answer from this. So this is just me running this on LangChain, right? We'll use only Colab for the rest of this class. So sorry, please. What do you mean by What do you mean by please? What do you mean by are we just going to be using Colab for the rest of this class? Yeah, basically, right? Because it's easy for us to share the notebooks. If you want us to start like sharing like complex GitHubs, we can, but I mean just because of we are trying to take care of we that are just starting up amongst us. So that is why we are going to be using notebooks. Um, or almost done. This will take time. I mean, of course, but yeah, basically this is just the simple rack system with LangChain. So please, let's let's let Lang let's read off the documentation of LangChain against next class. Please, I am asking. Can we do a secret token? No, you cannot. You cannot. Adura, you cannot because it does not have the capacity of Colab to do that. I don't think you can do that with Jupyter Notebook. Except they must have updated it, but to be honest, that's been a while I actually even did anything on Jupyter Notebook. Even Colab, I barely use Colab. Most of the time, it's always me writing codes on VS Code. Right. It's always me writing code on VS Codes. So yeah, while this is taking time, maybe we should just do like a recap of what we learned today. Okay, so it has. I think this thing is still. Let me go on. I think it's still hallucinating because it's bringing up a lot and a lot of things. But there are no. It's bringing out a lot and a lot of things that are not even necessary. That are not necessary because this is definitely hallucination. Because it's now generating. It's just giving us. It's generating the questions for us. So, in terms of trying to curb this, right? Maybe a ranker will help. Yeah, not maybe a ranker will help, and find and using a better embedding model too will help. You already ran your temperature before. You already ran your code before changing your temperature. Yes, I already did. Yes, I already did. But maybe yeah, because all these are just just generating different things, which is not nice. Well, I mean, we'll fix that before next class and check it again. So yeah, no, it's already 9:04. I don't want to take any of us time. Um, thank you very much. Let me do a recap of what we learned today. Let me do a recap of what we learned today. So that we can see my face now. So what did we learn? What did we learn today, right? Yeah, I did not reduce the temperature probably. I should have done that actually. I should have done that, and that would reduce the whole hallucination. Or not hallucination right now, but the way the model is just bringing things, being creative in quotes. Um, yeah. So what did we learn today? I mean, did a refresher on rack, talked about rack, talked about the concept of rack, talked about the components of rack, the retrieving part, the similarity search parts, the generation parts. Talked about we gave breakdown of okay for the similarity. Now we talked about FIAS, which is Facebook AI similarity search. We talked about tokens. We talked about how tokenization works again. We talked about how even embeddings work again. How our texts are assigned numbers, right? How similarity search helps us in retrieving words. Then how the LLM when plugged in helps it make so much sense. Right. So thank you very much. I think that that's just a summary of that. And we talked about LangChain too. So thank you very much. Thank you very much. Please, I'll also be sharing the paper. I think I should actually let me look for the paper now. I promise to share a paper with us on a use case of rack system in healthcare for drug information for drug information. So I'll be sharing that. I'll be sharing that with us. I'll be sharing that with us. Give me a second, okay? I'm sharing that with us. Interestingly, I don't know where I think I would give it. I'll give it to our assistant if that can be shared. Yeah. Um so that's all for what we have to do for today. So please don't forget, read up on LangChain. Read up on LangChain. Sorry, what is giving you error, Buluwatife? What is giving you error? What is giving you error? What is giving you error? Oh, what is the temperature? So temperature, like I've always explained in every class, um, like I've always tried to. Sorry. So temperature, like I've always tried to explain in every class, is to reduce how models are being creative in their answers, right? The higher the temperature, the more liberty you give the model to be able to generate basically random completion or random inference. When you reduce it, it helps to, when you reduce it, it goes straight, it gives you specific answer straight to the point. It does not have to start generating random questions, right? Does not have to start generating random questions. So yeah, I hope that is all. So I've pasted the research paper I wanted us to read. Yes, temperature controls randomness. Thank you, Omotosho. That makes output more precise and direct. You can increase and reduce temperature to your taste. Thank you very much, Omotosho, for that. Thank you. I wish I could. Oh, don't worry. I think she's already around. So okay, no problem. I'm trying to see how I can get the link to the research paper to you guys, but it will be shared with us, right? It will be shared with us. All right. So thank you very much for today's class. Had a very short time. Thank you. Let's let's do, let's do more of this. Let's do more of this. Let's make the class much more interesting. So we'll be starting off with we were talking about text, but now we'll start talking about voice and image generation. So thank you very much. Yeah.